Out in the darkness of space lies an object from which nothing can escape. Its gravity is so strong that not even light can get away. It is the strangest object in the entire universe. A black hole. So what exactly is it? How is it born? And how do we even see it? To escape any world, you must move faster than its escape velocity. Leave Earth, and that speed is about 11 kilometers per second. But squeeze enough mass into a small enough space, and gravity soars. Squeeze it far enough, and the escape speed passes the speed of light. And since nothing outruns light, nothing can ever leave. Einstein's theory of gravity predicted such monsters over a century ago. But a black hole is not a cosmic vacuum cleaner sucking in everything. From far away, its gravity is just like any other stars. Most black holes begin their lives as a truly giant star. For millions of years, fusion in its core pushes back against gravity. But eventually the star runs out of fuel to burn. With nothing to hold it up, the core collapses in a fraction of a second. The outer layers rebound and detonate as a brilliant supernova. But the crushed core is left behind, and its fate depends on its weight. If that core is heavier than about 3 of our suns, nothing can stop it. Gravity crushes it down without limit into a black hole. In that instant, a black hole is born. A black hole may sound simple, but it has a hidden anatomy. At its heart lies the singularity, a point of infinite density. There, our known laws of physics completely break down. Around it is the event horizon, the true edge of the black hole. Cross this invisible line, and you can never come back. Squeeze our sun into a black hole, and its horizon would be just 3 kilometers wide. Just outside, light itself can circle the hole in a glowing photon ring. Gas falling in piles up into a blazing accretion disk. Friction heats that gas to millions of degrees until it glows fiercely. Some black holes even fire titanic jets of energy from their poles. And a black hole bends the very starlight passing behind it. It does this by warping the fabric of space and time itself. So what would happen if you fell into one? Gravity would pull your feet far harder than your head. You would be stretched into a long, thin strand, an effect really called spaghettification. And near the horizon, time itself would slow to a crawl. To a friend watching from afar, you would seem to freeze at the edge. Your image would turn redder and dimmer and never quite cross over. But from your own point of view, you would fall straight in. You would slip past the horizon without feeling a thing. Beyond it, every possible path leads only to the center. What truly happens there, no one yet knows. Now here is the puzzle. A black hole gives off no light of its own. So how can we possibly see something that is perfectly black? The trick is to watch what a black hole does to its surroundings. As it devours a neighbor star, the hot gas screams out in X-rays. In 1971, one such X-ray source gave us our first strong suspect. A visible star was circling something invisible and incredibly heavy. Then astronomers turned to the very center of our own galaxy. There they watched stars whip around a dark, unseen point. One star, called S2, races around it once every 16 years. Its orbit revealed a hidden giant, 4 million times the mass of the Sun. This discovery won the Nobel Prize in 2020. But the most spectacular proof came from 2 black holes crashing together. Their collision sent ripples through space-time. In 2015, detectors on Earth felt those ripples for the first time. It was the faint echo of 2 black holes, merging a billion light-years away. Then scientists linked telescopes across the whole planet into one. In 2019, they captured the first ever image of a black hole. It showed a fiery ring of light around a dark shadow in a giant galaxy. In 2022, they even imaged the monster at our own galaxy's heart. At last, the invisible had been made visible. Black holes come in wildly different sizes. The smallest are the collapsed cores of single dead stars. The largest lurk in the centers of galaxies. And they are supermassive. These giants can weigh millions or even billions of suns. Our own Milky Way hides one about 4 million suns heavy. Do not worry, though, it sits safely 26,000 light-years away. In between lies a rarer, mysterious class we are only beginning to find. And black holes may hold one final surprise. They are not truly black. Stephen Hawking showed they should glow with the faintest whisper of radiation. Over unimaginable spans of time, this makes a black hole slowly evaporate. In the far future, even black holes will one day fade away. But if they vanish, what happens to everything that fell inside? This puzzle, the information paradox, still baffles physicists today. Black holes remain one of the greatest frontiers in all of science. They are where gravity, space, and time are pushed to their absolute limits. And every year, we pull a little more light from the darkness. If you enjoy this kind of deep science, subscribe, and I'll see you next time.